Hello, and I hope you are doing well. Today we did a model of the underground explosion or subsurface explosion with the method over the barrier pipeline. Here we have the pipeline here. We have void in the pipeline. Here we have the CFRP layer to reduce the deformation of the pipeline. And here, if I use this option here, you can see we have TNT here, and here is the air, and under of that is the uh, soil. So let me click on animate. See, this is the expansion or TNT wave propagation and the CFRP damage here. See the CFRP. Let me check the final view. See here we have completely failed of the CFRP and the soil. You can see that here. If we click here, you can see. Let me check the damage variable here. This damage variable. Here we have Johnson Cook damage for the pipe. We have Hashing damage, compression fiber, tension for fiber, compression for matrix, and tension for matrix. Again, you can see the deformation. This is the huge deformation. And this is the final view. And now let me check it, the model in this view to check the volume fraction. Okay, now let me check the volume fraction. For instance, first the TNT, and use this option to make it more continuous. See, first this is the TNT, and this is the expansion of the TNT, and it moves through the soil and the air. But the wave in the air is more faster than the soil because the soil has more density than the air. And this is the last frame. And let me check volume fraction for soil. See here, the soil is red, and now we have soil here around the pipe and bottom of the pipe, and here it is the air, and you can see the TNT push the soil toward to the air and the pipe, you can see, and now you can see these are the soil inside the air. The TNT pressure moves the soil to the air. You can see we have mixing in two of the materials, and now we can check the air here, and then the plastic strain for the soil here, or this, and then the stress in the soil as the pressure, for instance, or in the TNT as the pressure. We can check it in frame by frame. See here, frame by frame. See, this is the TNT pressure. You can see. Okay, so now let me check the stress, and just let me replace the two parts CFRP. This is CFRP, not GFRP. CFRP and the pipe. And this is the stress. Click on animate. You can see the stress propagation in both part, and the damage and the deformation happen here. You can check the deformation also, or anything else. Let me, for instance, check the stress, check the damage variable for the composite. Now let me use this option, for instance, here. You can see this is the deformation of the soil, this is the deformation of the CNT, and here we have the another view. Oh, let me check here on the stress and click on animate. See the expansion of the TNT inside the domain. The domain is air and soil. and this is the last frame. You can see this is the last frame. Okay, so if you need to model the underground explosion, considering all the details of the materials, you can come to our website abaqusfm.com here. Find the English tutorial, click on the title, then you will have the geometry and explanation about that assembly, and then we have the step interaction load and the result as figures you can see here. The cost for the C, INP and English video file and the paper as the reference is 30 euros. You can use a PayPal account, Visa or MasterCard for the payment. Before that, contact me to this email. We have also a full package containing more than 400 tutorials about all things of the simulation and modeling in Abaqus. We have also some tutorials in ANSYS software, and it covers all things that you need to be master in simulation and modeling. Here you can read about the main titles here, and there are many subtitles in the main titles here. So if you want to provide this full package with more than 400 tutorials with affordable price, especially for students, contact me to this email, and then I will tell you about the full package and its price and the payment method. Thank you for your attention.